Hi everyone, in this video I'll be showing you how to do number 47 in our chapter 6 physics homework. So for 47 we really want to focus on setting up our diagrams. So we have a 0.5 kilogram object which is initially at rest, and so that's the first part, and we want to define a positive direction because that's really important in this problem. So I define positive as going right, but in this step the object is just at rest, doing nothing. Now, the second part of the problem is that on the object there is an applied constant force of 3 newtons for 1.5 seconds. And the initial velocity is 0 because it was at rest, and we have to find, for number A, for problem A, we have to find the final velocity. Then, in the third part of the problem, a force is applied in the opposite or negative direction for 3 seconds, and we have to find that final velocity. Now, I really want to point out that this final velocity is the same as the initial velocity in the third part, because this happens, the 4 Newton force is applied right after the object reaches a velocity of this final velocity. So let's solve for this final velocity first. So that's problem A. So we want to set up the equation I equals change in momentum, or impulse equals change in momentum, because then we have all components. We have force times time, we have the change in velocity, or that's what we're trying to find, and we have the mass. So that's the initial equation. And then when we simplify it further, it's F times change in t equals change in mass times velocity. Then when we plug in all the numbers, we plug in 3 newtons for F, we plug in 1.5 seconds for t, and then change in velocity means the mass, which is 0.5 kilograms, times the final velocity, which we don't know and we're trying to find, minus the initial velocity, which is just 0. So we could simply solve for just the final velocity in that case. So this is when you plug everything in. And when you simplify, multiply, divide, you get final velocity is equal to 9 meters per second. And that is this velocity here. So after that, there is a force on the object, which is 4 newtons in the opposite direction, which means that it's negative 4 newtons for 3 seconds. So we could just use the same equation, I equals change in P, or change in momentum, because we have velocity, force, time, and mass. Well, we don't have velocity, we're trying to solve for it. So in this case, we have F times change in t times equals change in mass times velocity. So in this case, we plug in negative 4 newtons for force because we defined positive going in the right direction, but this force is going in the left direction. And it's applied for 3 seconds, so change in t is equal to 3 seconds, and then change in mass times velocity is just 0.5 kilograms times the final velocity minus the initial velocity, which we found in this problem, which is 9 meters per second. So this is what it looks like when it's all plugged in. You really have to make sure you include the negative sign, because otherwise your problem will be messed up. The negative sign, again, is included because we define positive direction going right, but this force is going left. So when you simplify, we get negative 12 equals 0.5 times final velocity minus 9, and when we simplify even further, we get that the final velocity is negative 15 meters per second, or 15 meters per second going in the left direction. And that's your answer for B. Thank you for watching. I hope this helps.